we're going to talk about a few different notations that are going to be very, very critical for really the rest of whatever you do with math in your life. One of them is going to be a lot more useful and quick and convenient than the other. And so most of the time we will use one of these, but let's talk about them first, and then I'll tell you which one I would use more often. So the first one is set builder notation. So we're looking at building some set. Notice this is kind of the layout for it here. We have our brackets there. And we're going to be talking about, okay, so any x or whatever our variable is needs to satisfy these properties, and what set of numbers does it belong to? So if we look at this first one here and we're saying, okay, so our set of numbers, we're going to say, okay, sum x, remember that vertical line means such that, sum x such that, well, it looks like x has to be greater than or equal to 8. And what type of numbers are these? Well, these are values of x greater than 8. You could say that as long as x is an element, that symbol is saying x is an element of, well, we could say whole numbers, we could say integers, we could say natural numbers, because all of that is representing 8, 9, 10, 11. I'm just going to say integer. We couldn't say rational, we couldn't say real, because this is very specific. We're counting 8, 9, 10, 11. And so we need to make sure that set of numbers is representing what's happening there. Our second one, we're definitely talking about x, any x such that, well, clearly x is less than 7. We're very specific to that. And, well, if we're just saying x is less than 7, then we're saying x must be an element in our real numbers. There's nothing specific to this to say that it has to be an integer, or it has to be a natural number or a whole number or anything like that. So in set builder notation, we would say that this is going to be any real number. This one may be the most trickiest of all multiples of 3. Well, all multiples of 3, okay, sum x such that, well, all multiples of 3, we're actually going to represent x as like 3n. Any x such that x equals 3n, where n is an element in our integers. And why did I write it like this? Well, any x such that x equals 3n. 3n multiples of 3, where n is an integer. A multiple is an integer multiplier of, in this case, 3. And so multiples of 3 could be like -3, could be like positive 36, and we would get all those numbers if n is any integer value. -1, positive 12. If n is 100, then we get a multiple of 3, we get out 300. So here's our set builder notation. The other one is interval notation. Well, we can see a lot of different examples of what we might see here. If we're looking at inequalities, so we're representing our x being anything constrained in between a and b. Interval notation is going to use both brackets and it's going to use parentheses. The bracket, the very rigid, hard bracket right there, is saying that we can equal that value. Notice that x is in between our lower and higher bound, and so we have our a comma b, and we put brackets around it because we can equal a and b. Notice that here we cannot equal, and when we cannot equal, we put parentheses. Here we can equal a, can't equal b, so we do a bracket on a parentheses on b. And finally, can't equal a, but we can equal b, so parentheses on this side because we cannot equal a, but we can equal b, so we put a bracket. Here, these are unbounded inequalities. So x is anything greater than or equal to a. Well, if x is anything greater than or equal to a is the lower bound and infinity is the higher bound. In this case, we can equal a, so we put a hard bracket right there, but we can never equal infinity. So parentheses, because we can't actually equal it. In this case, x is less than a. Well, if x is less than a is actually the the higher boundary, and the lower bound would be a negative infinity because x can be anything less than a. Again, we can equal a, so a bracket can never equal an infinity, so you'll always put parentheses on that side. And notice how that's true as we go along through the rest of these. In these cases, we cannot equal a, so we put parentheses on the side of a also. Let's look at some examples here. If we want to put these in interval notation, x is in between negative 8 and 16, so we always put lower comma higher, least to greatest. We cannot equal negative 8, but we can equal 16. X is less than 11. If it's less than 11, the lower bound is a negative infinity. The higher bound is a positive 11, parentheses on both sides because we can't equal either one of those. Finally, well, this is a little bit crazy. We have an or right there, but I think we can handle this. X is less than or equal to negative 16. Well, that has its own interval. That is its own interval notation. So if we write that x is less than or equal to negative 16, that would be negative infinity to negative 16. Or x is greater than 5. Well, that would be 5 to a positive infinity with parentheses on both sides. We represent that or with a union symbol. It's this or this. So we've represented that first interval with our notation, we've represented the second interval with the notation, and then we put the union symbol to bring it all together. Personally, I like interval notation better. It's quicker, it's faster, it's less writing, and to me it makes a little bit more sense, and I like reading it better. And the more you use it, the quicker you get with it, the more confident you get with that interval notation. I want you to be confident with both of them. I would personally use this. The book will probably use both notations interchangeably, and we need to be able to read them both. And I'm fine with you using whichever one you feel more confident with. But I recommend and I prefer the interval notation.